Introduction. Ajay, what are you reading? I'm reading my chemistry textbook. Arjun, don't put that pencil into switch. You will get the electric shock. Electric shock? But why? Pencil is made up of wood and graphite, and both are non-conductor of electricity. Arjun, you must know that graphite is a non-metal, but it is a good conductor of electricity. I don't have any idea about that. Okay, I will show you with the help of an experiment. When we on the circuit, then multimeter shows an electric current reading. It shows that graphite allows the electric current to pass through it. Hence, graphite is a good conductor. Ajay, now I understand the point. And I want to know more about this. Graphite is an allotrope of carbon. Carbon is one element from the P block of periodic table. To understand more about this, first we have to study the P block elements. Students, today we will study about the P block elements. Objectives. At the end of this lesson, you will be able to define P block elements, define inert pair effect, understand group 13 elements, analyze physical and chemical properties of group 13 elements, explain
anomalous
properties of boron, analyze compounds of boron, understand group 14 elements, explain general characteristics of group 14 elements, analyze physical and chemical properties of group 14 elements, know about allotropes of carbon, analyze some important compounds of carbon and silicon. Definition. Elements of group 13 to 18 of the periodic table are collectively called P block elements. Boron, carbon, nitrogen, oxygen, fluorine and helium head the groups. The general electronic configuration of these elements is ns2np126. They involve the filling of p orbitals of their outermost shell. The maximum oxidation state shown by a p block element is equal to the total number of valence electrons. This maximum oxidation state is called the group oxidation state. Inert pair effect. The term inert pair was first proposed by Neville Sidgwick. The inert pair effect is the tendency of the outermost s electrons to remain unionized or unshared in compounds of post-transition metals. The term inert pair effect is often used in relation to the increasing stability of oxidation states that are 2 less than the group valency for the heavier elements of groups 13, 14, 15 and 16. Group 13 elements. The boron family. Boron family shows a wide variation in properties. Boron is a typical non-metal. Aluminium is a metal but shows many chemical similarities to boron. Gallium, indium and thallium are almost exclusively metallic in character. Electronic configuration. The outer electronic configuration of group 13 elements is ns2np1. Boron and aluminium have noble gas core. Gallium and indium have noble gas plus 10d electrons. Thallium has noble gas plus 14f electrons plus 10d electrons cores. Atomic radii. On moving down the group, the atomic radii increases. However, atomic radius of gallium 135 picometer is less than that of aluminium 143 picometer. It is because the presence of additional 10d electrons offer poor screening effect for the outer electrons from the increased nuclear charge in gallium. Ionization enthalpy. Its value does not decreases smoothly down the group. The decrease from boron to aluminium is associated with increase in size. The increase from aluminium to gallium is due to discontinuity in the ionization enthalpy. The increase from indium to thallium is due to inability of d and f electrons, which have low screening effect. Physical properties of group 13 elements. Boiling point of the elements decreases down the group. Density of the elements increases down the group. Melting point of the elements first decreases and then increases down the group. Boron has highest electronegativity. From aluminium, to thallium, electronegativity increases. Boron is a non-metal, whereas aluminium, gallium, indium, thallium are metals. Chemical properties of group 13 elements. Reactivity towards air. Boron does not react with air in crystalline form. Aluminium forms a very thin oxide layer on the surface which protects the metal from the further attack. Amorphous boron and aluminium metal on heating in air form B2O3 and Al2O3. With dinitrogen at high temperature they form nitrides. Reactivity towards acids and alkalines. Boron is unreactive with acids and alkalis even at moderate temperature. Aluminium shows amphoteric character and dissolves in mineral acids and aqueous alkalis. Aluminium dissolves in dilute HCl and produces dihydrogen. Reactivity toward halogen. Boron family elements react with halogens to form trihalides.
Anomalous.
Properties of boron. Boron is a non-metal having some metallic properties. It has electropositive character. Boron forms trivalent compounds. It liberates hydrogen on boiling with NaOH solution. Binary compounds of boron are known as borides. Boron trifluorides easily reacts with Lewis bases such as NH3 to complete octet around boron. Some important compounds of boron. Borax. It is also called sodium tetraborate decahydrate. It has been found that crystalline borax contains tetranuclear units of B4O5OH4 whole 2 negative. Hence, its formula is given by Na2 B4O5OH4 into 8H2O. Crystalline borax is sparingly soluble in cold water, but it is readily soluble in hot water. When borax is heated, then it loses water molecules. On further heating, it turns into a transparent liquid which solidifies into glass-like material known as borax bead. Orthoboric acid. Orthoboric acid, H3BO3, is also known as boric acid. On heating at 100 degrees Celsius, it gives metaboric acid HbO2. Metaboric acid, when heated at 140 degrees Celsius, gives pyroboric acid H2B4O7, which when heated at high temperature gives B2O3. Orthoboric acid is very weak acid, but it can function as a strong monobasic acid in presence of a polyhydric alcohol due to formation of an anionic complex borospiranic acid and liberates H+ ions. Example. Let's take an example. What happens when borax solution is acidified and boric acid is heated? Let's see the solution. When borax solution is acidified, boric acid is formed. When boric acid is heated, boron sesquioxide is formed. Uses of boron and aluminium and their compounds. Boron is used in many cleaning products, detergents and bleaches. It is used to produce glass and ceramics. Borosilicate glass has a fantastic resistance to thermal shock. Boron filaments are used as light but high-strength material for aerospace structure. Boron carbide shields can be used as control rods in nuclear reactors. Low density and strength make aluminium ideal for construction of aircraft, lightweight vehicles and ladders. Corrosion resistance and low density leads to its use for greenhouses and window frames. Good conduction of heat leads to its use for boilers, cookers and cookwares. Easy shaping make aluminium a good material for drink cans and roofing materials. Group 14 elements. The carbon family. Carbon is second most abundant element in human body. Its abundance in Earth's crust is about 320 parts per million. In free state, it occurs as diamond, graphite and coal. Silicon is the second most abundant element on the Earth's crust and is present in nature in the form of silica and silicates. Germanium present only in traces. Tin occurs mainly as cassiterite, SnO2. Lead mainly occurs as galena, Pbs. General characteristics of group 14 elements. Electronic configuration. The valency shell electronic configuration of carbon family is Ns2np2. The inner core of the electronic configuration of elements in this family also differs. Covalent radius. Covalent radius considerably increases from carbon to silicon. Thereafter, a small increase in radius is observed from silicon to lead. This is due to the presence of completely filled d and f orbitals in heavier members. Ionization enthalpy. The ionization enthalpy decreases down the group. The first ionization enthalpy of group 14 members is higher than the corresponding members of group 13. Electronegativity. Due to small size, group 14 elements are slightly more electronegative than group 13 elements. The electronegativity values for elements silicon to lead are almost the same. Physical properties of group 14 elements. Metallic character increases on going down the group. These structures change from giant molecular lattices in carbon and silicon to giant metallic lattices in tin and lead. The change in bonding from covalent to metallic down the group causes a decrease in melting point, boiling point, and first ionization energy. On going down the group, the increasing metallic character causes a general increase in density and conductivity. Chemical properties of group 14 elements. Reactivity towards oxygen. Group 14 elements, when heated in oxygen, form oxides. They form mainly two types of oxides, monoxide and dioxide of formula MO and MO2. Oxides in higher oxidation states of elements are generally more acidic than those in lower oxidation states. Reactivity towards water. Carbon, silicon and germanium are not affected by water. Tin react with water and form dioxide and dihydrogen gas. Lead is unaffected by water due to protective oxide film formation. Assessment. Before proceeding further, let us know how much have you learned. Drag and drop the correct option.
Anomalous.
Properties of carbon. Carbon is mainly used as fuel and it is a good reducer. In metallurgical process, metals having moderate electropositivity are extracted from their oxide ores by reduction with carbon. Oxides of high electropositive metals at high temperature react with carbon forming corresponding carbides. Carbon atoms have the tendency to link with one another through covalent bonds to form chains and rings. This property is called catenation. Allotropes of carbon. Graphite. In graphite, each carbon atom is attached with three other carbon atoms, forming two-dimensional hexagonal ring structures through sp2 hybridization. There is a little force of attraction between these two layers. Therefore, graphite is soft and can be cut with a knife. Each layer can slide over the other, making it slippery and can be used as solid lubricant. Each carbon atom in graphite contains a free electron, which is responsible for its conductivity. Diamond. In diamond, each carbon atom is linked with four other carbon atoms through sp3 hybridization, forming three-dimensional rigid structure. Due to small size of the carbon atoms, they form closely packed crystalline structure and becomes hard, and diamond is used as abrasive. In diamond, carbon atoms do not contain any free electron. Therefore, it is a bad conductor to electricity. Fullerness. Another allotrope of carbon is known as fullerness, containing 60 or 70 or 84 carbon atoms in a molecule. These molecules are cage-like in the shape of football structure. They can be used as lubricant at very high temperature. They have superconductivity property at very low temperature. They find use in the preparation of weightless fiber of high tensile strength. Some important compounds of carbon. Carbon monoxide. Carbon monoxide is prepared by adding concentrated H2SO4 on formic acid at room temperature. Carbon monoxide, thus prepared, is passed through caustic soda solution and then dried by passing over P2O5. It can also be prepared by the action of concentrated sulfuric acid with oxalic acid. Carbon monoxide is a colorless combustible gas. It is a neutral oxide, but at high pressure and high temperature, it behaves like an acidic oxide. Carbon monoxide can function both as an oxidizer as well as reducer. Oxidation number of carbon in carbon monoxide is +2. Carbon dioxide. Carbon dioxide is prepared by the action of dilute hydrochloric acid on marble. Carbon dioxide is an acidic oxide and acts like a dibasic acid and can form two types of salts. At high temperature, carbon dioxide can function as an oxidizer. Some important compounds of silicon. Silicon dioxide. Another name of silicon dioxide is silica. It occurs in several crystallographic forms like quartz, cristobalite, and tridymite. Silicon dioxide is a covalent three-dimensional network solid in which each silicon atom is covalently bonded in a tetrahedral manner to 4 oxygen atoms. Silica, in its normal form, is almost non-reactive because of very high silicon-oxygen bond enthalpy. It reacts with HF and NaOH. Quartz is extensively used as piezoelectric material. Silica gel is used as drying agent and as a catalyst. Silicates. The basic structural unit of silicates is SiO4-4, in which silicon atom is bonded to 4 oxygen atom in tetrahedron fashion. A large number of silicates minerals exist in nature like feldspar, zeolites, mica, and asbestos. When silicate units are linked together, they form chain, ring, sheet, or three-dimensional structures. Glass and cement are 2 important man-made silicates. Did you know? Carbon has been known to man since approximately 3750 BC. Carbon was first used by the Egyptians and the Sumerians for reducing copper, zinc, and tin ores in the manufacture of bronze. Boron is an essential nutrient for all green plants. Carbon has the highest melting and sublimation points of all the elements of about 5800 degrees Kelvin. The universe's atoms of boron were made by nuclear fusion in cosmic ray collisions. Most of the universe's boron was made in this way before the formation of our solar system. Summary. Let us summarize what we have learnt. Elements of group 13 to 18 of the periodic table are collectively called p-block elements. Inert pair effect is the tendency of the outermost s electrons to remain unionized or unshared in compounds of post-transition metals. In group 13, boron is a non-metal, whereas aluminium, gallium, indium, thallium are metals. Aluminium shows amphoteric character and dissolves in mineral acids and aqueous alkalis. Carbon is second most abundant element in human body. Its abundance in Earth's crust is about 320 parts per million. In free state, it occurs as diamond, graphite, and coal. Carbon atoms have the tendency to link with one another through covalent bonds to form chains and rings. This property is called catenation. Carbon monoxide is a neutral oxide, but at high pressure and high temperature, it behaves like an acidic oxide. Silicon dioxide is a covalent three-dimensional network solid in which each silicon atom is covalently bonded in a tetrahedral manner to 4 oxygen atoms.